Hey guys, today I am going to talk with you some basic, or you can say the main functionalities of operating system. Okay, and if I talk about the good books for this subject, then one is Galvin and one is Tannenbaum. These two are good books. So who are preparing for NET and GATE, they can also refer these books, Galvin and Tannenbaum. Okay, so let us start. First of all, what is operating system? See, you find this definition everywhere. It is an interface between user and hardware. Okay, so that is not new, but I am just going to tell you what this interface means. Okay, now before proceeding, I must tell you operating system is what? It is a system software. Fine. Now what is a software? Software is a set of tested programs with documentation. Programs plus documentation. See, that is a software. Or you can say tested programs plus documentation. This complete is a software. Documentation means that you can see the user manual, how to operate that particular software. Okay, how to use that software. So now software are of two types. One is application software and one is system software. Now what is difference between these two? Application software and system software. See, application software basically designed for some specific task. Okay, like for example VLC, your MS Office, your Windows Media Player, those are application software. They do some specific task. Okay, and what is system software? System software basically operates the computer hardware, or in second another term you can say system software provides platform for application software to run. Okay, see, here application software would be there, here system software would be there, and then here we have computer hardware. See, application software, user will use application software and system software will provide platform to run the application software to run, and then user can access this hardware, something like this. So system software, see, operating system comes under which category? Operating system is a system software, it is not application software. Some other system softwares are, you can say, linker, loader, debugger, these are some system softwares. So now what this term means, interface. Why we need operating system between user and hardware? Here we have user, here we have computer hardware. Fine. And in computer hardware you can say CPU, IO devices and memory. Now can't the user access these computer hardware without operating system directly, like this, direct interaction with this hardware? Maybe it is possible. See, first of all let me tell you some real life example. See, when you want to start a fan, then there would be a switch, and when you on that switch the fan starts. Okay, if switch is not there, then is it possible to start the fan? Maybe it is possible because maybe there are behind the switch there may be some circuit having 2 or 3 wires, and when you attach or join 2 wires, then fan will work. Okay, so that switch, why the switches? So everybody cannot operate with those wires. Everybody doesn't know how to handle wires, but even a small kid know how to use the switch. Fine. So that switch is what? An interface between user and that hardware, or you can say the fan. So in simple terms, if I say, then interface is what? Interface makes things easy, you can say. Okay. So same way operating system, if operating system is not there, then can user interact with this hardware? Maybe user can interact, but in that case, for accessing every device, if user want to access CPU, then user have to write complete program to access this CPU. Fine. First of all, to access that particular device, particular hardware, and then the user have to write whatever he or she wants to perform with that particular hardware. Okay, see, if second scenario is what, we have user, here we have operating system, and here we have hardware. Fine. So it is an interface between user and hardware. Let us take one example. When a user is writing any C program, fine, and you are writing printf in that program. You know, when you write printf, then what will happen? Something, if you want to print hello, then you will write printf, and then here you will write hello, and hello will be, you know what should be the action. The hello would be printed on the screen. Okay, but that is not so simple. When printf would be there, then what operating system will do? Operating system will make a system call to this write. Whatever the printf will do, the code for this function, the code for this action is written in this write. Here the code would be written. Okay, and using this code you get the output. It is not that simple that you simply write printf and you get the output. Operating system will do some system calls and then you will get the output. Okay, if this is not there, operating system is not there, then what you have to do is, you cannot simply write printf. You have to write this code every time you want to use this printf. Fine. And obviously writing, I don't know how, this line contains how many lines, but every time you want to use printf, then at all the time, at every time you have to write this code. So this would be very complicated. If operating system is not there, maybe some only experts can access this hardware. Fine. Because first of all you have to write a complete program to access particular hardware, then you have to write what you want to do with that hardware. But if operating system is there, you simply write what you want to do. Every other things, every other work will be handled by this operating system. And second thing is what, if this is, suppose this one is the scenario, then if user 1 wants to access CPU or IO devices or memory, then he is some expert and he has written a complete program for accessing the CPU, and he is now using the CPU. And if suppose another user want to access this CPU, then it would not be possible, because until the user 1 release the CPU, user 2 cannot access this device. So this is also responsibility of OS. Then how, when and for how long user can access a particular device. It is not like that user 1 will using the CPU for a long time and all the other users obviously then cannot access that particular hardware device when user 1 is accessing that particular hardware. And why this happens? Because between user and this hardware device there is no other authority who can say that you have to release this hardware now and I am going to assign this hardware, this device to another user. Okay, there is no one, because user is directly interacting with this hardware. But if operating system is there, then it would be possible. Okay, if user 1 is accessing a particular device and user 2 want to access, or maybe another process want to access that device, then operating system will manage it. So this is the main funda of operating system. It makes things easy, or you can say it is making accessing of this hardware easy for the user. User need not to worry about the internal or the background details. Like in switch, you are not worried about the background details of the switch. When you on the switch, then which wire will be attached with which wire, and then the fan starts. The user doesn't know anything. User is unaware behind what is behind the scene. Okay, so that is the funda of operating system. Because of the presence of operating system, user can easily access the hardware devices. It will manage everything. Okay, now what are some basic functionalities of operating system? First one is, you can say it is a resource manager, or you can say resource allocator. Resource manager or resource allocator. Now what resource means what? Maybe it may be CPU, it may be memory, or it may be some IO devices. So operating system manage or allocate these resources to different processes, or you can say to different user. If two or more user want to access this CPU, or maybe you can say if two or more processes want to access the CPU at the same time, then to which process the CPU would be allocated and for how long, that would be taken care by the operating system. Fine. See, at same time in your laptop or in your computer, many processes are running. If you open the task manager, then you will find out that some background processes are also running. And if you have opened that, if you are typing in Microsoft Word, साथ you are listening song, and at the same time you are surfing on internet, at the same time you are doing many tasks, many processes are running in the computer system, or some background processes are also running. Okay, when you open the task manager, then you will see that this CPU is allocated 2% to this process, IO devices are allocated 1% to this process, something like this. So this allocation is handled with the with operating system. To which process, which device would be allocated, and at what time and for how long that device would be allocated to that process. Fine. So this is also known as processor management. One functionality is processor management, or you can say process management. Same thing, to which process CPU would be allocated and for how long time, that would be managed by the operating system, and this thing would be done with the help of scheduling or process scheduling, you can say. We will discuss the scheduling, many types of scheduling algorithms are there, we will discuss in detail later. Okay. Next is, you can say, memory management. See, it is a manager, na? So it manages all the resources, CPU also, that is processor management, you can say, memory also, so memory management you can say. Now see, memory management, if you are saying, then it is basically, it is particularly concerned with RAM, or you can say main memory. If you want to execute something in your any program in your laptop or in your PC, then it must be allocated some space in main memory first of all. After that, execution can start. Fine. Take an example of, see, if you have written a program to print hello and you have saved this with hello.c, and when you compile that, then first of all this would be converted into object file, you can say hello.obj file, because your system can only read the object file, it cannot read the program written in natural language, because you write the program in English language, and it must be converted into machine language, that is 0 or 1, or you can say that object in object file. Now when you want to run this or this, see, this .c file and .obj file, these are stored in secondary memory, and when you start to executing this program, then that would become a process. And at this time, when program starts execution, then first of all some space would be allocated in main memory, that program comes in main memory, and then execution starts. Without allocating a space into main memory, no process can execute, no program can, you cannot execute any program. Fine. Now at the same time, many programs or your many processes are running. Fine. And all the processes are in main memory, because for running the process, that process must be in main memory. And as you know that size of main memory is not so big, it's very limited. Which process would be there in main memory and for how long, that is also decided by operating system, because you cannot put all the processes at the same time into main memory, because the size of main memory is small. Find the which process you have to swap out into the you can say maybe in secondary memory, and then again swap into the main memory, that thing is handled with operating system. That is known as memory management. Okay, how the main memory is to be allocated to the processes. Fine. Next you can say IO management, or you can say IO device management. This is also a functionality of operating system. IO devices means maybe your keyboard, your mouse, printer, scanner, these are IO devices. Now Let us take an example. If we have one printer and to that printer many computers are attached, we have 2 or 3 computers and one system having attached with a printer, and these are also attached with this printer. Okay, so this can also be print something using this printer, this user can also print something with this user, but we have only one output device, that is printer. So this is that operating system have to manage which process, or you can say which user is going to access this printer, okay, and at what time. It is not like that every user can use the printer at the same time, only one user can access the printer at one time. Okay. So this is the responsibility of operating system, to allocate, to manage all the IO devices among the processes, or you can say among the user. Now next you can say storage management. Then if I say storage management, then this one is particularly related with the disk, or you can say hard disk, or you can say the secondary memory management. Fine. How the data is to be stored permanently on the hard disk in the using the tracks and sectors and all, and how the data is to be accessed from the secondary memory. That is also taken care by operating system, maybe with the help of file system, you can say NTFS file system, FAT file system, and many types of file system are there. Fine. And in file system the data is to be stored, you can say, in the form of directories, then within directories there are subdirectories and files and all. Fine. So to manage the hard disk, operating system is responsible. Okay, that is also a functionality of operating system. And next you can say security. Now what does that the security, or you can say protection? Security means, see, if your system is password protected, then when you open your laptop or system, then it asks to enter the password, and if that username or the password is correct, then only you can access the files. Okay, so it is the responsibility of operating system that the operating system takes care that no unauthorized user can access the files. So operating system save your password, and then when any user enter that password, then matches that password would be matched with the saved password, and if that is correct, then only you can access the files, or you can log in. Or that security is also at the level of processes. At the same time many processes are running. Fine. Like suppose P1 is also there, P2 is also there, P3 is also there in the main memory, and at one time P1 is running, and then again it allocate the CPU to P2, then P3, because see, it is like if you have one processor only in your system, then only one process can execute at one time. It is not like that 2 processes are running at the same time on that CPU. Okay, that is not possible. Okay, only one process can be allocated to the CPU at one time. Fine. That is a different thing. If you have multi-core processor, then maybe parallel processes, the running of parallel processes is possible. Fine. So if 2 or 3 processes are there in the main memory, or you can say then this is the particular, you can say, PCB. I'll discuss PCB later. You can say the working space of P1, this is working space of P2, and this is working space of P3. So these processes cannot interfere with each other. That is, you can say, that security at the process level, and this is also the responsibility of operating system. Fine. No other process will interfere with execution of another process. That is taken care by operating system also. By the way, there are many functions of operating system, but I have just discussed the main 5 functions. You can say it is also resource manager, or you can say process management, memory management, device management, storage management, and security and protection. These are 5 or 6 main functionalities of operating system. And see, this process management, memory management, device management, this disk management also, security and protection, these are the complete unit. So here I have discussed in brief, And when you open the Galvin, then you find that memory management is itself a complete unit. Process management is itself a complete unit. Fine. So, we will discuss in detail later about these. I have just discussed the basic or the briefly what are the functions of operating system and what is operating system and what is this interface means. Fine. Now, if I discuss goal of operating system, then mainly we can say two goals of operating system. One is convenience and one is efficiency. Fine. One is convenience and one is efficiency. Fine. What does that convenience means? It means easy to use or user friendly. Fine. Your operating system should be very convenient, very user friendly, very easy to use. Fine. That is why you can say that at one time the market share of Windows operating system was 95%. And nowadays also, if you see in your friend circle, then you find out that in majority they have installed Windows in their laptops. Fine. Although now the market share of Windows is around 82%. Fine. And it's 95%. It's all because of convenience. That operating system is very easy to use. Any naive user can access that particular software, that particular operating system, sorry. Fine. Even that user don't know anything about hardware or software, then that user also can access the laptop or can do something on laptop and PC. It's all because of operating system. Now, second is efficiency. See, this is the main goal for supercomputers and mainframes, because supercomputers and जो mainframes होते हैं, those systems were operated by some experts, and experts don't want that it should be easy to use. For those, the main goal is efficiency, that the particular operating system should be efficient. But for end users, for those who are not expert in using operating system, for those user, for the naive user, that operating system should be convenient. Main goal is conveniency in that case, but for mainframe and supercomputers, the main goal is efficiency. Fine. So, these are two goals of operating system. Okay. Now, one more thing I want to tell you, types of interfaces. I guess everybody know GUI and CUI, graphical user interface and character user interface. Or if in another term you want to say, then you can say system call and system command. One is you can access the hardware with the help of system call also and system command also. So, you can also say these two are the types of interfaces, or simply अगर आप बोलना चाहो that you will find everywhere the types of interfaces are two types, one is GUI and one is CUI. In GUI, what is basically the access is with the help of images, or you can say the icons, and here commands will be required. User will write a command, then particular action will be performed. So, this is basically in the case of DOS, direct operating system, and Windows is what? Having GUI interface. Okay. So, in next video I will discuss with you the types of operating systems. Till then, take care. Bye bye.